Ladies and gentlemen, Reaction. This is Death from Space, Gamma Ray Bursts explained by the channel Kurzgesagt in a nutshell. There are cosmic snipers firing at random into the universe. What are they and what happens if they hit us? We are screwed if that happens. But yeah, gamma rays are the highest frequency of the light spectrum, opposed to the low frequency, which is radio waves, microwaves. So gamma ray bursts, I think it happens when supernova happens, Titanic supernova happens, and that gives the waves of gamma rays that comes, one after another. Black holes sends jets of gamma rays whenever the disk around the black hole, when it gets heated up a lot, it shoots the jets, on top, in the top and on the top, in the north part of the black hole. Is that the way to say it? Doesn't matter. So yeah, the jets that comes out of the black hole, those are the gamma rays. So yeah, gamma rays are damn powerful. Gamma rays would basically destroy the ozone layer and then cook every life on the planet. Obviously they are really radioactive, so they would cause breakage of all the cells and things in us, kills all the life on the planet. Not to mention, if the ozone layer gets killed, then obviously the sun's radius and also will kill us. So yeah, it will be really bad. So there are so many things that can kill us just from the in the space, the asteroids and things. Gamma ray is one of them. So yeah, that's all this one. Remember people, if you like my reaction, don't forget to like, subscribe, check out the reaction. There's a link in the description. Check out the casual plays like Kurzgesagt in a nutshell. I've done quite a few videos from this channel already. If you haven't seen them, check the playlist out. Check out the playlist too, like Interhistorian, Old Sakashi Production, History, CGP Grey. Yeah, that's all this one.
Imagine if you could gather the energy from every star within 100 million light years, from thousands of galaxies, each with billions of stars. Imagine you could take this kind of power and use it to fire the biggest superweapon in the universe. Imagine the damage you could do. It turns out, you don't need to imagine it. These exist, and they're called gamma ray bursts.
Yeah, see, what he said, I just remember the Death Star from Star Wars. In that, one thing I had issue about that is, Death Star takes all the energy from a star and destroys a planet. What the hell? That energy from the star has power to destroy hundreds of planets, not just one planet. So that felt like a bit weird to me, like you just gonna suck all the energy from the star and then just destroy a planet or two. Come on. So I guess, the Death Star's ray has to be gamma ray, maybe. Why not?
But what are these cosmic snipers? And what happens if one takes a shot at Earth? To understand gamma ray bursts, we first have to understand gamma rays. Gamma rays are electromagnetic radiation, waves which carry energy just like visible light. Visible light is a tiny part of the electromagnetic spectrum. It's the part your eyes can see. At lower energies, there are radio waves, microwaves, and infrared. And at higher energies, ultraviolet, X-rays, and gamma rays.
Yeah, see? It starts to become extremely high frequency waves. Gamma rays, requires immense energy to create. I mean, if radio waves and microwaves, they travel long distances with relatively low energy compared to something like gamma rays. If you want to create a super power gamma ray beam, you need immense power. Like in the video says, the power of lots of different stars and things like that to create a long-lasting gamma ray, because it's a high frequency, it requires high energy. So whenever gamma ray comes from the long distance, is basically something like star just exploded, or obviously black hole just spewed out a lot of energy from its accreting disk or something, and maybe two black holes colliding. Maybe I don't know if that will create gamma rays or not, but it's something like that. Immense energy is needed. So something like that, if happens really close to us, which I think scientists would know, because maybe we can detect it, if there's going to be supernova close, no. Are there any neutron stars or something that close to us? No. Is there any black hole? So I think we can predict it if there is going to be massive gamma ray burst is coming that could harm us. But if it happens, we are basically screwed. If one of the things goes undetected, like somehow massive star that's about to go supernova goes undetected, and if it happens, gamma ray bursts will come at the speed of light, obviously, and we are all screwed before we realize it.
Gamma rays are incredibly powerful. A single gamma ray photon is more energetic than a million visible photons combined. Their high energy makes gamma rays a form of ionizing radiation, meaning they are energetic enough to break apart atomic bonds.
Atoms don't look like this.
This makes them dangerous to you and me. Ionizing radiation disrupts the delicate biochemical machinery that keeps us alive, like a 9mm bullet through a clock. Fortunately, on Earth, the ozone layer blocks gamma rays, filtering them out before they can harm us. But if the atmosphere blocks gamma rays from space, how were gamma ray bursts, or GRBs, from space ever discovered? During the Cold War, the USA sent up spy satellites which could detect gamma rays from Soviet nuclear tests in space. They didn't see any bombs, but they did observe faint bursts coming from space, lasting only a few seconds. To date, this made...
Yeah, see, that's the really after thing, right? Cold War, because of Cold War, lots of major scientific discoveries were done. Apollo program was basically because of the Cold War. So, Cold War really advanced the science field. This is one of those instances. Oh, look at that. Soviets could be doing, nuclear tests in the space. Let's just send the satellite there. Oh, look at that shit. There is this thing as gamma ray bursts, coming from the sky, space. Then discover like, oh, look at that. These are supernova that is exploding, giving all this gamma ray burst. Look at that. Then eventually black holes does that too.
Be the only major scientific discovery made by spy satellites that we know about anyway. Astronomers use telescopes that see different kinds of light to make their discoveries, and these spy satellites gave them a new pair of eyes. They were a mystery for 30 years.
Well, one of the spy satellites was the first ever Hubble satellite, prototype or something. That was a spy satellite that was looking down. Then NASA said, screw it, we need a bit bigger version of this looking up. And then the Hubble telescope was launched, and it, discovered a lot of things. So in a way, another spy satellite became Hubble, and that discovered a lot of things.
Years, but eventually we discovered the source of a GRB, a galaxy 6 billion light years away. If a GRB can be seen from such a distance, then it must be incredibly energetic, releasing more energy in a second than the Sun will in its entire 10 billion year lifetime, making GRBs the brightest events in the universe. So where do they come from? GRBs accompany some of the most violent cataclysmic deaths in the universe and the birth of black holes. There are two types of gamma ray burst, short and long, and each has their own source. Long GRBs last about a minute, and scientists think they are produced by supernova, when the core of a massive star collapses to become a black hole. Short GRBs last a second, and are produced when two neutron stars in a binary merge. Over millions of years, their orbits decay by emitting gravitational waves. Once they're close enough to touch, they crash and splash into each other, forming a black hole. Both supernova and neutron star mergers make the same thing. Black holes surrounded by a magnetized disk of gas left over from their parent stars. In these environments, the rotation winds up the magnetic field, which funnels hot jets of particles traveling at nearly the speed of light. The gas in this funnel creates two tight jets of high-energy gamma rays, like a celestial laser gun. So unlike other cosmic explosions which spread out and fade, GRBs stay focused and can be seen from much further. Any more detail would require too much mathematics for a YouTube video. The universe is full of these cosmic snipers, firing blindly and randomly into the dark, and they're hitting us all the time. On average, we detect one per day. Fortunately, most are harmless. All the bursts we have detected so far originated outside the Milky Way, too far away to hurt us. But a nearby GRB could be disastrous. If one goes off within a few light years of us, it would totally cook the surface of the Earth, or at least the half that's facing it. But even a more distant GRB could still end life on Earth. And it wouldn't need to score a headshot to kill us. If originating from a few thousand light years away, it would be 100 light years wide by the time it reaches us, washing over the solar system like a tidal wave. Again, the ozone layer protects us, but it's better equipped to handle the trickle of ultraviolet from the sun. A gamma-ray burst would overwhelm it, leaving us exposed to deadly solar radiation. Ozone takes years to replenish itself by natural processes, which is more than enough time for the sun to burn the Earth sterile, or at least to kill most complex life.
Yeah, it's not just that. Whenever supernova happens, there are, in a minute, it's a, slow gamma ray burst, like you said. When neutron star, collides, it creates a quick gamma ray burst, this lasts seconds. When supernova happens, it lasts for about a minute. In that lasting of minute, it's waves of gamma ray burst. First wave comes, it kills off the ozone layer like that. Then the layers come that start to affect, all the life on the planet. Basically, everybody starts to get fucked, cancers and things, so, everything will start to burn up and things like that. And obviously, sun is just there. Sun is like, I'm gonna help out. So basically, all the life is screwed if that happens. Gamma rays are so powerful that if something, even at 4,000 light years, if something like supernova happens, we are screwed. And I'm pretty sure, we would need to invent some kind of a dome type of thing over our planet to protect us. But I don't see that happening anytime soon. Right now, we don't even have a program of a missile that could stop an asteroid hitting us. We don't even have that. We can do that, but we don't even have the program for that. So building a damn dome, entire, encompassing the entire planet, any kind of dome type of thing, I don't see that happening anytime soon. So if, suddenly we find that there is, a gamma ray burst is coming, and weirdly it's just coming in a few decades, which would be weird, because I'm pretty sure we could, discover if some kind of supernova gonna happen much sooner, and the warning would be in hundreds or even thousands of years long. But if weirdly, oh look at that, there is a star that was hidden from us for whatever weird reason, and it's about to go supernova, and it's gonna hit us in few decades, then we are fucked basically.
In fact, this may have already happened. A GRB has been suggested as one possible cause of the Ordovician extinction 450 million years ago that eradicated almost 85% of all marine species, although it's pretty much impossible to prove. Gamma-ray bursts could even be one reason we don't see life anywhere else in the universe. They might be wiping clean huge chunks of it on a regular basis. It's been suggested that because of GRBs, only 10% of all galaxies might be hospitable to life similar to us.
Yeah, that is true.
So, are they going to kill us? Probably not. In a galaxy...
Things like this tells me that, it's very like, it's like a Russian roulette, living anywhere in galaxies, basically. Because there are many things that could kill us. Gamma ray burst is one of them. And gamma ray burst just, left and right gets shoot out whenever supernovas and things like that happen. Black hole just shoots jets. So like he said, only 10% of the place could, harbor life, sustain a life, because everywhere else, gamma rays and things like that would basically kill life. So it feels like a Russian roulette. Out of 100, maybe just 2 survives or something like that.
Galaxy like ours, there may only be one GRB per millennia, and to harm us, they must be close and directed at us. But since gamma rays travel at the speed of light, we won't know one is headed our way until it arrives. So there could already be a GRB on its way to kill us all, and we won't know it until it hits us, and we're dead. This video was sponsored by squarespace.com/nutshell. Death from the sky could come around any second.
Yeah. That obvious animation was a funny thing. You won't be able to see something like a star that you can say, oh, I want to make a wish. If you see it, gamma ray is already here and you're screwed. So, yeah. Damn. This Kurzgesagt is just an awesome science channel. But sometimes the videos always end with this kind of dark note. Oh, look at that. That is something that could kill all of us. Alright people, if you like my Rick Sunday, like, subscribe, check out the Rick Sunday, there's a link in the description, check out the cards, please check out the end cards, and I'll see you next time.